Hello all, welcome to LDX classes in this concept series of science and technology, where in this class we shall deal related to cryogenic engine. Most of the students feel difficulty in understanding what is a cryogenic engine. In this class we shall decipher what is a cryogenic engine. Okay, see, the article is dealt by Srinivas. Okay, let's have the focus on cryogenic engine. First of all, an engine. What does an engine consist? Okay, see, we don't need to read about the technicalities, but we should know what and how it works. Engine actually produces the thrust. Thrust means pulling force. Thrust means the pulling force. The pulling force to an object is called thrust. The same thrust would be generated by an engine. An engine in a car or an engine in a bike actually helps for the movement of whole the body, right? So in the same way, to place any object in the satellite, we need the space vehicle. Clear? The space vehicle. The space vehicle is called as the rocket. Clear? See, often when we see cars or bikes, it generally goes with the road, means it has to be applied on the road, right? But when you take rocket, it goes against the gravitational force, right? Rocket actually travels against the gravitational force. So if any object actually going against the gravitational pull, it requires a lot of fuel to be burned to lift the object against the gravitational pull. So it requires a great engines. Clear? So in the same way, rocket engines actually developed or moved from the solid stage to liquid stage, means we generally use solid propellants, means fuels, liquid propellants means fuels, and after that it is cryogenic. An engine which uses the cryogenic fuel or cryogenic oxidizers. It is also called cryogenic oxidizer. So these cryogenic oxidizers actually uses the liquid helium, oxygen and everything, and you shall be seeing all these things. Clear? Yes, have concentration here. So what is a cryogenic engine or cryogenic stage? That we generally refer in the space rocketry. Clear? Actually the cryogenic stage actually places itself in the last stage of the vehicle. Clear? In initial stage it is provided the propellant with solid, and after that the propellant or the fuel is liquid, and in the third stage or the last stage actually equips with the cryogenic fuel. Clear? Cryogenic fuel. So cryogenics is the study of production behavioral patterns at extremely low temperature. So cryogenic is studying about some objects or materials at extremely low temperatures like minus 150 degrees Celsius, means the fuel has to be fueled at minus 150 degrees Celsius. Why? Because see, the same can survive in the space. If something is equipped with minus 150 degrees Celsius, it can survive in the space without any objections or any of the things. Clear? When the same rocket enters into the space, the fuel should not be get into solidified form, or it should not be liquidated. It has to be maintained at minus 150 degrees Celsius. So for this to achieve, it needs to be in cryogenic condition. Clear? Are you getting the importance of cryogenic? So cryogenic stage is technically a much more complex system while compared with the solid and liquid fuels or propellants. Clear? Yes. A cryogenic engine provides the more force than actually what something would be produced because of solid and liquid propellant rocket engines. Clear? So the efficiency of cryogenic is very great. So from this we got that the efficiency of cryogenic engines are much more greater than the conventional engines. So in cryogenic we use the liquid oxygen. In cryogenic we use the liquid oxygen. It is also be written as LOX and with liquid hydrogen. Clear? Liquid hydrogen, which is also written as LH2. Clear? Liquid hydrogen. Actually these two acts as propellants and they liquefy somewhere around minus 183 degrees Celsius to minus 253 degrees Celsius. Clear? They can be stored in these greater critical conditions. So when we achieve this up to 183 degrees and 253 degrees, we can able to go for the cryogenic upper stage engine. This is what India achieved as of now. So if something is achieved at cryogenic stage, the same rockets or fuels can be used to for longer distances. Clear? To have the deep study on the space, rockets or the satellites has to be sent the longer distances. The longer distances can be sent when we achieve the greater cryogenic efficiency. Clear? So cryogenic fuels that require these to be stored at low temperatures. Clear? Yes. So in space, as we cannot see any of the environment, the absence of environment actually fails the conventional engines to survive, but the cryogenic engines efficiently can solve this problem. Clear? So yes, so right now we have to observe some picture so that to understand the cryogenic upper stage. See, have a look at this. So now I shall explain. See here, this is pictorial representation from newspaper. The ABC of cryogenic upper stage means the full details about cryogenic upper stage. See, I am getting it as zoom. See, you can observe this, all these things. See, this is GSLV Mark III rocket, which actually consists of, see, the payloads are in upper stage and the next stages are cryogenic. See, this is the cryogenic stage. Clear? And this is 110 liquid Vikas engine. It is the Vikas engine and these are boosters. Boosters provide extra thrust for the rocket to move. Clear? This is these are orbits and see these are payloads. All these are payloads. Clear? So when you observe this, that cryogenic stage actually consists of helium liquid. See, helium liquid. Helium is used to maintain the pressure in cryogenic chambers. Clear? Pressure in cryogenic chambers, and the same is used liquid hydrogen and liquid oxygen. Hydrogen and actually oxygen are pushed towards the combustion chamber. Combustion chamber is something where it uses fuels to produce the combustion. Clear? Liquid oxygen and liquid hydrogen from respective tanks are fed by individual booster pumps to main turbo pump at 40,000 rpm. Clear? Rpm means revolutions per minute. Okay, 40,000 revolutions per minute to ensure a high flow rate of propellants into the combustion chamber. This chamber has to be sent. See, this liquid hydrogen and liquid oxygen has to be sent to turbo pumps at 40,000 rpm and where the combustion actually involves. Clear? The cryogenic stage carries 28 tons of propellants in two tanks that provides a thrust of 20 tons. Clear? The thrust actually is at 20 tons. This is the nozzle, the combustion nozzle as the picture goes. Clear? See here, the two tanks with liquid hydrogen at 253 degrees Celsius and liquid oxygen at 183 degrees Celsius. Okay, these are called oxidizers connected to combustion chamber. Clear? I think you got related all the knowledge of the space technology and remain see, this is the ABC of cryogenic upper stage. Clear? Yes. And right now this would make sense what is a cryogenic upper stage engine and how it actually works in real life, right? Yes. Thank you, and stay tuned to the concept series where we shall be providing very important critical things related to science and technology in very easy and lucid manner. Thank you.